Assalamu alaikum dear students. Bismillahir Rahmanir Rahim. Welcome in lecture 27 I think so. In this lecture I am basically covering another determinate frame which is right uh, shown on my screen, and this is a kind of frame you see that it has two inclined members. So in x direction basically we have x1, x2 and x3. Okay, so we have three axes, or you can say bay 1 and bay 2. We have two bays, and let's say this is A, this is B and this is C. So the bay width is 18 feet, so this is constant. Clear? This is Z1, this is Z2 and this is Z3. So Z1 and Z2 is 10 feet and Z2 and Z2 and Z3 is 6 feet. So we need to edit, clear, the frame. So let's see how we will model this beam or this frame structure, and one thing, okay, I will explain this in later part. Okay, so K feet, new template, let we will use this one. Number of story you have 2, clear. Story height, let's say I use 10. I have different story height, one is 10, the other is 6, so you can use 6 or you can use 10. Number of bays we have 2, but the number of bay width both are 18 feet. Check this one, edit grid designs. The spacing of the X grid is okay, but you have to make changes there. Select spacing and just only change this 10 to 6. Clear? Because from Z1 to Z2 you have 10, and but from Z2 to Z3 you have 6 feet. Okay and okay. So this is the frame. Now we have to develop this frame in this model. We don't need these two members, and as well we don't need these two members, and as well I don't need this one, I don't need this one, and as well I don't need this portion. So delete it. Clear? Select the line element and draw your rest of beams, this one and this one. Clear? And make it okay. Now you have to assign loads. This joint is hinge, this joint is hinge. You need to assign load to this member. Assign frame load, distribute it. This should be 0. Okay. Okay. Modify. Okay. K feet, this one, force, and there you need your local axis, because this is the point which I want to explain you. You see that this member is inclined. The member is inclined, but the loading is, you see, is perpendicular to this member. Okay. Now that's why we need to apply this loading in perpendicular direction. If you select the global axis, so your global axis will be in this position. If you select the gravity direction, so the gravity direction will not be perpendicular to this element. There will be some like in this shape, which will be inclined to this member. So we need to apply this loading in this pattern, perpendicular to the line element. They must make angle 90 degree. There it don't you can say make a 90-degree angle. So this is wrong. We need this pattern. Clear? So here we have to work on local axis. Okay. So first of all, we need to bring the local axis and to show the local axis on this member to identify that whether in which direction the local axis are basically assumed. Clear? So before going to assign the loading, you need to bring the to show the local axis. To bring the local axis or to show the local axis, you need to check this option and select this option, local axis for frames. Okay. These are the local axes for these frame elements. Okay. Now you see, if you select 3D, you must need to understand the global axis. You see the X, the red color denoting the X axis basically. Clear? And the blue color is basically denoting the Z axis, and the green color is basically denoted the Y axis. But you must know that local axes are basically representing by 1, 2, 3. Okay, so X will be denoted by 1, Y will be denoted by 2, and Z will be denoted by 3. Clear? But this is a kind of local axis. Okay, this is for local axis. But if you have global axis, so the representation of global axis, this is global axis. I explained this in full detail in my session 1. So please watch those videos if you want to learn more. Okay, so in global axis, this is 1, this is 3, and this is 2. Okay, this is the difference between these two axes. Clear? And what is global axis and what is local axis? You need to watch those videos. I explain these axes. Clear? So here, once I'm assigning the load, okay, I need to select the direction of that load, and that direction will be along 2, 2, because the load is acting along 2, 2. So there you can see the Y axis. This is the Y axis. Clear? This is the Y axis. So this is 2. This Y axis is denoted by 2. So if I select the assign and distributed load, okay, you need to change from global to local axis, and there you see 1, 2, 3. You need to select 2. Okay, and you have to apply the loading in a negative direction because Y is acting in upward direction and we need to apply the loading in downward direction. So therefore we need -3. Clear? Okay, the load are assigned. So this is the way that how we will assign loading. Clear? Now select this member, assign, frame, distribute it. Okay, select global axis. Now the axis, the load is basically here you can see that the loading is acting in this direction, and your X, this is your X and this is your Y. These are global axis, not local axis. Clear? So this is positive and now the load is with negative. Clear? Both are in opposite direction. Clear? So therefore I select minus, I insert 1.5. Clear? The direction will be x. The direction will be x. Okay, and the rest of the thing is okay. You can change this, okay, either this one or either this one, doesn't matter, because we don't apply any type of loading there in this member. If you apply any loading on this member and you add some extra loading on this member, then you need to check out this. Okay, so now it doesn't matter. Okay, so load are assigned. Let's see, we will check the analysis model. Do not run. Okay, run now. I think so. This is lecture number simple example number 32. Save it and see the results. Oh, the results are okay. Congratulations. Okay, these are the results. We have 24, but we have 23. So roundabout this is close. We have 22. Okay, this one is okay, and this one is also okay, and this one is also okay. Clear? 9.32. This one is 24. Okay, and this one is okay. So this is the procedure that how we will analyze a 2D determinate frame. And next session we will start the analysis of indeterminate frames, as well as we do examples on determinate frames, but a little bit complicated loading and complicated pattern of elements. So if you have any question, any suggestion, please share with me. Watch the video and enjoy. Thank you.